Hello everyone, my name is Tasneem Safdari. I am a student of IIPS DAVV pursuing MCA. I am in third year. In today's video, we are going to discuss the end semester paper. In this particular video, I'll be discussing question number 1 and the rest questions in the next videos. So let's start. So question number 1 states, take a real world problem and explain how each crisp DM phase would be applied. Include at least one specific task under each phase. So this is the part A of question number 1. So let's get into it. Real world problem, predicting customer churn for a real retail store. So customer churn refers to customer who stop buying products or stop engaging with the company. So for a particular company, if we have particular customers and they are not currently buying products from us, or they are not engaging into it, so the retail store wants to identify each customer early so that it can take preventive actions such as sending offers, discounts, or personalized messages. So these are done to increase our sales. We are taking a real world problem which is predicting customer churn for a real retail store. So what are the different phases of crisp DM? So first is business understanding. This is the first phase where the objective, goals, and constraints of the projects are defined for a business perspective. So we are defining the objectives, goals, and constraints for a project. The aim is not technical but business clarity. So what is our business, what is our objectivs, what are our goals? So these are all identified in it. So how it is applied? The retail store wants to reduce customer churn and improve customer retention. And second is management wants a model that can predict which customer are likely to stop purchasing in next 3 months. So we are predicting it beforehand that what all measures could be taken, or we are predicting which customer will stop buying a particular product after or in next 3 months. So the cost of customer acquisition is higher than customer retention. Hence, predicting churn has financial benefits. Now, what are the specific tasks? So define project objectives like predicting customers likely to churn, and identify business success criteria like increase retention by 10% within 6 months. Identify constraints, limited budget, limited historical customer data, only last 2 years data available. So we are identifying the constraints like we have limited budget, limited historical customer data. We have only last 2 years data available with us. So this is the first phase of crisp DM. Now second phase is data understanding. In this phase, all relevant data is collected and studied. So we collect data. Now we have first identify our aim and objective. What is our project, what is our aim? So now we are collecting data from from the particular sites which we can collect, and we are studying it. So data quality issues, patterns, and relationships are identified. So we are identifying what are the issues, means what is the quality of data, patterns, and relationships between the data set. Now, how it is applied? The retail store collects data such as customer demographic information. So retail stores needs to collect this all data. So from this phase, we are particularly collecting the data. Purchase history like frequency, amount spent, last purchase date. So these are the purchase history of a customer. Next is loyalty program status. Now website या app activity, support or complaint logs. So initial exploration helps the team understand the data and its limitation. So when we are collecting data, we get to understand it. We can identify the limitations from it as well. Now, what are the specific tasks? Collect raw data from CRM databases, transaction logs, loyalty program records. So, we need to collect the raw data from this sites. Now, perform exploratory data analysis, like check distribution of purchase frequency, identify missing values. So, we have a raw data. We need to now we are performing an exploratory data analysis, which is known as EDA. So we will check the distribution of purchase frequency, then identifying missing values, like some customers have age or missing age or income, so we need to identify those missing values. Now detect outliers such as extremely high purchase amounts, so we need to detect this. Next, use visualizations like histogram, correlation plots to spot trends. So we need to identify the trend in data. So how we will do it? We'll plot it in histograms or correlation plots, and then we'll identify the common trends from it. Now third is data preparation. This is the most time consuming phase. The goal is to convert the raw data into a clean usable data set for modeling. So we had identified the goals, objectives of our business, then we have collected the data. Now we need to clean that data. So this is the most consuming, because we have raw data and we need to clean it, like filling in missing values. So we are cleaning and taking only the useful data sets for modeling. So how it is applied? The retail store needs to transform various types of data into machine readable form. So we need to convert it into machine readable form. So what are specific tasks? First is data cleaning. So we are filling missing age values using median age and removing duplicate customer entries. So we are doing this task, which is data cleaning. So we are filling it with missing values. We are removing the duplicate customer entries. Second is feature engineering. Create new features like average purchase interval, days since last purchase, total spend in last 6 months. So we are creating new features which will help us to identify which are our regular customers, how long they have been purchasing, or how long they are the part of this company, means as a customer. So we'll be introducing this, creating this new features using feature engineering. Next is data transformation. Encode categorical variables, example membership type, gold, silver, bronze. So we are dividing it into categories, like what is their membership type. Now normalize numerical values like purchase amount, page visits. So we are normalizing it. Then data splitting, divide data into training and testing. So we know that we have a data set, means we are identifying the data set which is useful. So we need to divide data into training and testing. So training is 80% of our task, is 80% is training and 20% is testing. So this is data splitting. We are dividing our data into training and testing. Now fourth is modeling. In this phase, different predictive models are built, trained and tuned. So modeling means we are predicting models, like we have data, then we have to predict the trends which we will do models. So how it is applied? Several machine learning classification algorithm can be used to predict churn. So we have discussed that we have a raw data, so we have to convert it into machine readable form. So when we give this to machine, they identify we have algorithms that can predict our churn. So we have to have data which is in the machine readable form. So what are the specific tasks? Build initial models such as logistic regression or decision trees, random forest, gradient boosting. So we can perform all this, means we have initial models. Now tune hyperparameters like tree depth, number of trees, learning rate, and select model based on initial accuracy and performance. And then we will select models based on initial accuracy and performance. So we have initial models, then we will tune hyperparameters like number of trees we have used, depth of the trees, and then we'll be selecting models based on initial accuracy and performance. Now fifth is evaluation. This phase tests how good the model is is using various metrics. So we need to think that we have made a model, so how accurate, and we will test it that how good our model is. So if the model does not meet business goals, the steps may need to be repeated. So we will again go to phase 1 and repeat the steps if the model does not meet our business goals. So how it is applied? The model predictions are compared with actual churn data to determine how accurate and useful our model is. So specific task, evaluating using matrix, like we have a confusion matrix. In this we'll take actual and predicted, and then we'll compare it. So we need to find it, we need to find accuracy, precision, recall, F1 score, ROC, AUC. Validate the model on test. So using matrices, we'll classify this accuracy, precision, recall, F1 score, ROC, AUC. We will identify this, and then we'll validate the model on the test data set. We'll take test data set, and then we'll validate the model whether our model is accurate, good enough. So we'll identify this. Now compare multiple models and choose the best one. Example, random forest with highest F1 score. So we have given various data sets, and now we'll compare multiple models. So we might have identified multiple models during our process. So we'll identify the best one. We'll compare multiple models, and then we'll identify the best one from it. So this was evaluation phase. Now sixth, once the model is selected, it is deployed into real business environment. We have selected the model. Now we are deploying it in real business environment. So the retail store integrates the churn prediction model into its CRM systems. Now deploy the model so that it runs weekly and assign each customer a churn probability score. Set up alerts for the retention team when customer churn risk exceeds 70%. So these are our specific task. Deployment means we are putting our model into real business environment. So what are the tasks it is performing? So when we deploy the model so that it runs weekly and assign each customer a churn probability score. So it will run weekly, and it will assign a probability score, and it will give us the alerts, like it will give us when a customer churn is reached 70%, so it will give us a alert. Now automatically generate personalized offer for high risk customers. Seventh is monitoring and maintenance. Models degrade over time because customer behavior changes. This phase ensures the model remain accurate and relevant. As time changes, we need to make changes in our model as well. So the model may not be accurate enough as it was in starting because the customer behavior patterns changes. So we can apply this monitoring and maintenance in it, means this phase to make sure that our model behaves accurate and it is relevant. So continuous monitoring helps identify when model needs retraining. So we'll continuously monitor it. So track key matrices such as prediction, accuracy, and precision over time. So we will be keeping track of this. Now retain the model every 3 months with new sales data, and update features with new business data becomes available. Example, new loyalty benefits, new buying patterns. So we'll update our features with this. So this is the final summary. In this we have crisp DM phases. First was business understanding. So we defined the churn So we define churn reduction goals, and example of task are identifying KPIs, objectives. Second was data understanding, explore customer data, EDA, missing value detection, data preparation, clean and transform data, like feature engineering and coding. Then it was modeling, so we'll build ML models, so train LR, RF, DT. Now evaluation, measure performance, accuracy, precision, recall. Deployment, implement model in CRM, weekly scoring pipeline, monitoring, maintain long-term performance. Without degrading our model, we are maintaining a long-term performance. And retaining, and the examples are retaining and tracking. So this was part A of question number 1. Now let's move on to part B of question number 1. So differentiate between structured, unstructured, quantitative and categorical data with real world examples. So aspects of comparison, on what basis we are comparing. First column is structured, second is unstructured, third column is quantitative, and fourth is categorical data. So meaning and definition. So data is arranged in a predefined organized manner, usually in tabular form, rows and columns. So this is structured data. We have defined the data is arranged in a predefined and organized manner, like in tabular form, which have rows and columns, and the data does not follow any fixed structure, format or organization. So it is unstructured data. Next is quantitative. Data consists of numerical values that can be counted or measured. So we have numerical values in which we can count and measure it. Data that represent categories, labels or groups rather than numeric values. So the quantitative data contains numerical values that can be counted or measured, and this data represents categories, labels or groups rather than numeric values. Now nature of data, highly organized and standardized, because it is stored in form of tabular, means it is a tabular data in rows, columns, so it is highly organized and standardized. Raw, messy and not standardized. We have sometimes we get raw data, we need to clean it. It is very messy because we have very duplicate entries, missing values, so it is not standardized at all. Numeric, measurable objectives. So numeric, so we can measure it, we can find mean, median, and we can perform other mathematical operations as well, because it is numeric data. And qualitative, descriptive, non-numeric, because we are dividing it into categories like blood group or this, like these things. So qualitative, we have qualitative data. We have descriptive also, means it is descriptive. It is descriptive in its nature, it can describe its feature, but it is non-numeric. Now stored in relational databases, spreadsheets, SQL tables, Excel sheets. So we store in relational databases or spreadsheets, like we have SQL tables, Excel sheets. So we are storing it in the form of tables, rows or columns. Stored as text files, PDFs, image, audio, video, social media data. So this is like PDF, text files, audio, video, images. So this is unstructured data. Now stored as numbers in tables or data files. So in the form of numbers, we can store it in the tables or data files. Stored as categories in tables or survey forms. So in categories, like in tables or survey forms, we have categories, we have to select one. So it is categorical data. Now requires the fixed schema, means column names, data types. So this is a fixed schema. No predefined schema. Structure varies widely because it is unstructured. It do not have any structure. So no predefined schema. No specific schema required beyond numeric format. Can have predefined categories but no numeric schema. So it requires a schema. This unstructured requires no predefined schema because its structure varies widely. In quantitative data, no specific schema required beyond numeric format. Can have predefined categories but no numeric schema. very easy to query using SQL and other tools. We can find from tables very easily by performing SQL. If we have one information, we can perform SQL and we can get all the information. Difficult to search requires NLP, text mining or ML techniques, because finding something from a video is very difficult as compared to from a table. Easy to analyze mathematically or statistically. We can perform statistical or mathematical operations. Easy to group or count, because it is in categories grouped, so we can count and we can group it, but not suitable for mathematical operation because it is non-numeric. Analysis. Traditional data analysis tools, like we have SQL, so we can perform analysis. Advanced techniques like NLP, video processing. Now we can perform statistical analysis like averages, correlation, regression, frequency counts, mode, bar charts, chi-square test. These all can be performed. Now sorting, filtering, joins, aggregation. So these are the possible operations which are performed on SQL tables as well, which is sorting, filtering, joins, aggregation. Sentiment analysis, pattern detection, image or video recognition. Arithmetic operation and statistical modeling. Grouping, categorization, hot encoding for ML. Easy to feed directly into ML models. So what is relationship with ML? So easy to feed. We can feed directly into ML models. Must be converted. We need to convert text into vectors, images into pixels before ML. Directly used in numerical ML models. Need encoding like label encoding, one-hot encoding for ML. So easy to, we can directly feed into ML models because it is converted in tables only, in tables and raw data form. Now text need to be converted into vectors, so these have to be converted before putting it in ML. Directly used in numerical ML models. And needs encoding like label encoding, one-hot encoding for ML. Now example, student records bank transactions and tables in transaction tables, like we can store student transaction, bank transactions and employee databases. Here emails, YouTube video, WhatsApp text, photos, CCTV footage. So these are all unstructured like CCTV footage, YouTube videos. Height, weight, marks, number of purchases, salary. So this is all quantitative. Height, weight, number of purchases, salary. Gender, blood group, product type, customer segment like gold, silver, bronze. So these were all categorical data. Advantages: high accuracy, we can easily manage it, we can perform, we have reliable queries which can give us the output. It is structured storage, means it is stored in a structured way, captures rich information. Unstructured data, it has a rich information because it is raw, deeper insights, more natural to human communication, enables precise decision making based on measurable values, help categorize population and perform group based analysis. What are the disadvantages? Requires rigid structure, not suitable for complex data types, difficult to process, needs high storage and advanced algorithms. So in structured, we need a rigid structure. We should have a structure to store it. Not suitable for complex data types. Now unstructured, it is difficult to process. We need high storage and advanced algorithms to store it. Cannot represent opinions or categories. Cannot perform arithmetic operations. Limited statistical use. So this was all about these four categories, with this structured, unstructured, categorical and quantitative data. So we have compared them on this all basis, and we have also discussed the part A, which was crisp DM, and had taken a real world examples for the same. So this was all about question number 1 of end sem paper. we'll be discussing the remaining questions in the next part of the video. You can look to my channel for the playlist. I hope you liked it. Thank you so much for watching.